As long as it sounds good, I mean, things you need.
Good evening, everyone. Please let's confirm you can hear me clearly and loudly.
Yes, we can hear you.
Okay, thank you very much. I would want us to wait at least 10 more minutes for other people to join. We just have 43 on the call now. So afterwards, we can proceed. Tonight is going to be a beautiful and wonderful one. And I hope everybody enjoyed their day. While we wait, I think I can just unmute one person or the other to tell us about the little task. Then let us call it assignment. What were the challenges you encounter? How do you counter it? How do you solve it? I know we have engineers, big men in the house. So please, if you want to do the honor, just raise your hand and let me unmute you. Samuel David, you know how to talk. Since I know his name,
Yes, sir.
Good
it's
evening,
me and
sir.
you back to back.
These other people are not coming online. That's serious. Good evening, sir.
Yeah, good evening, Samuel.
Yes, sir.
So, how was the assignment?
It was quite taxing because I'm just leaving the work right now. I'm just leaving work right now. So I was
Oh,
working and I was very just don't even have time because our machine just want to kill us today. So I've been working throughout the day. Seriously. So I don't
I
really have
can
much
relate.
time. Seriously, but at least I try to do something, bro.
Yeah, that's good. That's good. I can
Yeah.
actually relate because I'm also not around. I had to travel for work, so I'm just getting back home and I have to also do the assignment. It's not that I will give it and I will not do it. Means I don't know
Yeah. Okay,
it.
that's good. That's good. At least
Yeah, we all have
I,
to do
I,
the
I,
assignment.
yeah. I couldn't finish, so that's just the problem. Because of the
No
time.
problem. We'll review this night. I think the goal is just
Okay.
to have everybody have something on their layout page so that we can work with it.
Okay. Because
Yeah, thank you.
the thing was, I could have finished it yesterday, but I was having a little bit challenge because I was trying to use a good mounting panel for it, but I was not getting the size I wanted using. So,
we'll tackle all of that today.
uh
I came prepared. Thank you. Senior man, Alfred is here, our boss.
okay. All right, sir.
Yeah, thank you.
All right.
Senior man, I beg now, follow us talk.
Good evening, everybody.
Good evening, sir.
Good evening,
Good
Oh,
evening.
sir.
Good evening, sir.
Hope you all had a great day. Uh, Me, I've not done my assignment, but I'll copy you people while you are doing it. So we'll be ending our beautiful automation, our electrical session today. So everybody should be attentive. You have a project, and the project might make you sweat, but be attentive. It's not the end of the world. You'll be able to do it. So I wish you all
Have
good luck.
we, yeah, have we had a girl speak before on this session? I don't know. Let's hear from the women. How is the assignment? What were the challenges? We have Sophia here. Where did you disappear to now, Sophia? What did you feel? I thought I saw Sophia somewhere here now. If you are still on the call, you can raise your hand. I saw another person.
Good evening, everyone.
Good
Not the only
evening.
girl named girl, not the only girl they named Sophia. Oh.
Oh,
I dey always raise my hand for this group. Alfred will not unmute me. He will not answer me.
Sorry, sorry,
it's a
He
bad
sorry.
person, don't
always
worry.
abandon me.
Sorry.
This group, I was thinking now is only for men.
No,
Mm?
Sorry. I was thinking you're a man. Sorry.
exactly the name. That's why
Ah,
I didn't even
Jesus.
bother call the name when I was scrolling. I like,
Oh God.
yeah.
Well, the assignment has been really taxing. Oh, I won't lie. You do it one way, another one will come, and then again, lights, NEPA, data, everything combined.
Yeah, that's the
Nigeria's
goal.
problem has been affecting us here, but it's good. It's been good. I've been surviving.
Yeah, it's good to hear that. Thank you very much. Whew, I think, okay, 4 minutes more before we start today's session, I think, because we have a lot to cover today, and I would appreciate if everybody can just work together. And while I'm working, you are working, so we don't have back and forth of, sir, why do you do this? Why do you reach this place? And so on.
Well, I think you're muted, yeah?
So I think our tutor might be having a little network issue, but I'm sure it will soon be back. So you all should get your EPLAN ready. You know, EPLAN is to load if you want to open the software. So go and open the software. Make sure every data is opened. You have synchronized everything, and you are already on the working environment. I'm sure you will join us too. For those complaining
Yeah,
about
sorry,
this,
Mr.
okay.
Alfred.
Yeah,
I'm
yeah, yeah,
sorry.
yeah.
Sorry for
That-
the break. I had to pick a call. That's why. I'm really sorry. So Where do we stop? Mr. Alfred is taking us away. Oh, Damilare Adekoya, the assignment mad o. Nobody agree share update. Hmm. Hmm. That's why it's called update, because it's always up to date. Wisdom. Thank you very much. So once it's 8:10 now, we'll start. I think we've had enough for the class. What happened? Why are you crying, sir? Olugabi, what's his name? There's someone I'm looking for. Is there anyone that can share his or her screen? Let's see what you have on your e-plan. We should start with that. If you know you've done something you are confident enough to show, and nobody's bashing anybody, we're just here to learn. Some people are sending some stuff to me, but I won't lie, I was busy throughout today, so I could not even open some messages on WhatsApp. I'm sorry about that. Yeah, you're not expected to draw the panel. It's just the schematic I want to see also. So I want everybody to have their schematic ready, then you'll be building your panel based on your schematic, not based on my own schematic. I'm building my own, you are building your own. So based on all the components you have and all the components I have. So is there anyone that want to show? Then I'll allow you share your screen, or we should just move on. I think in the absence of none, we can start the class. Okay. So we'll be using the chat box in case you have any question or I'm going too fast, because I want this session to be as practical as possible. I want everyone to be able to, after this session, you should be able to at least use the layout part of EPLAN. You should be able to draw a panel. You should visualize your panel, start from your selecting your enclosure, sizing up your enclosure, knowing the rating. After the end of this class, I want everyone to be able to at least do something on EPLAN when it comes to 3D design. So we're starting now. This is not what I want to be showing. So this is my own assignment. This is my own little assignment, because after giving the assignment, I had to also find a way to get it done. I don't know if there's need to explain the control side, how the whole, what's this thing called? The whole ultrasonic sensor works and everything, because some people were in my DM asking about, sir, the ultrasonic sensor, sorry. Okay. Some people in my DM trying to say, sir, the ultrasonic sensor, how will it work? Which one are we using? This and that. So I think I'll just do a brief run around or run through the whole design that I have here. So first of all, we have the incomer line 1, line 2, line 3 to a terminal block. Then from the terminal block to the main isolator. Then from the main isolator is distributing forward. So from your main isolator, if you check it, if you are trying to cross-reference, you can see we have input power 1 here, input power. If you check what we have at the end of this space, is also what? Pump input power from this page. So that's, if you cross-reference it, you see that the power is coming back from this page. So the 3-phase is powering this pump. From the 3-phase supply, it goes down to an MPCB. Some people use an overload. Sorry, I don't know if you can still hear me. Please let me have reactions, or just say it in the chat if you can still hear me, because the network here is not solid. Okay, I think we're good. Okay. So, like I said, some people make use of overload relay and breakers, which is super okay also, no discrimination. Then we have contactor, the K1 we're using for the motor, we're using DOL control, not too much drama. Then your motor also has an isolator, the one connected on field close to the motor, in case you want to work on the motor instead of going to your panel to switch it off and all of that. Then this is the cable size for the motor. This is the earthing route for the motor. Then we're using a three-phase motor, 7 horsepower, like I stated, DOL, M1, the label for the motor. So let's go to our 24 volt power supply. We have a live and neutral incomer, most especially supplied by the customer or anywhere. Then it goes into your terminal block. There's a breaker also for that. So from the breaker, it feed to the other component. The component we're feeding to now is the setup. I don't know. I think we're still together, yes. So the component we're feeding to now is a setup. This is the Siemens setup. AC input 230 volts. That's why we're using live and neutral. Then output is converted to 24 volt output. So it comes in line one, live and neutral, then connect the P. Then this also, the output of this goes into a breaker. Then from the breaker, to add extra protection, please, if I'm going too fast, let me know in the chat box. Someone said yes. Okay. Okay. So this is what we have. We have a PSU, power supply unit, which converts what is this? It converts AC 230 volt to 24 volt. The 24 volt is what we need for the control side of this design. So for that, we also power it with the infeed from this part here coming from the maybe customer side, the line live and neutral. Then we connect it to a breaker. Then from the breaker, we just extend it to show that it is going out. Then coming back to this part of the drawing, you see this is the Siemens setup, single phase setup. There are three-phase setup. This is a single phase setup. Live and neutral, you connect it to it. Then the output of the setup is connected down here. So the output is already in what 24 volt format. Then you also put the 24 volt into a breaker. You don't just connect it directly to a more device. A more device is a 24 volt distributor. So what it does is it creates channels for your 24 volts. After powering it up with 24 volts, after powering it up 24 volts, you now have up to four different channels where you can tap 24 volts from. So this is out 1, out 2, out 3, and out 4. And out 4. So what happens is you are using a common ground. You are using a common ground, which is 0 volts, and then you have 24 volts from this place. You can put it to one terminal block, 24 volts from another place. You can put it to another terminal block, 24 volts from here. So it help you make your work easier. So in case of troubleshooting, maybe there's short circuit from one end of the terminal block, you don't start tracing back to the maybe breaker or anything. You know which channel that is coming from, then you can always work on that. So let's go to the ultrasonic sensor to make use of. So this is a typical ultrasonic sensor, normally open contact on EPLAN. I didn't download any EDZ for this. Just go to your EPLAN macro, then search for sensor. Under sensor, you scroll down, you see your, sorry, DL is used for small motor. Let's say between 1 to 5 horsepower. Say 1 horsepower implies the error score. I don't know if this was where I missed some of the class due to work. Would appreciate your explanation on this. Okay, I think we'll get back to this. So moving on, then the ultrasonic sensor, the output would go to the terminal block also. Then from the terminal block, we're powering a coil, a relay, 24 volt DC relay coil. Then we'll go to the control side, which is where was causing a lot of havoc for a lot of people. Okay, so for the control side, what I did was, this is an emergency button to stop the whole process in case of emergency and all of that. Then we have a feedback from the NPCB. So the NPCB has a normally open and normally closed contact where you can wire 24-volt to. So in case of trip of overload or short circuit, you can always get a feedback here that will just shut the control side also. Then this is for the isolator of the pump. So in case on the field the isolator is turned off and then you are trying to on it, you can also sense that okay, there's something wrong here. Then let's go to the selector switch. Let's go to the selector switch I mentioned earlier that people were asking. So this is a typical example of selector switch. Someone was
Sorry.
asking that why I didn't
Hello.
twist. Yeah, I'm with
Uh,
you.
okay, so please, can you like make me the co-host so I'll continue recording? Since the host
Okay,
is not there again and the recording
okay,
has stopped.
sir. Let me do that. 1 minute, please.
So we don't miss.
Trying to look for your. Okay. Yeah, I did it.
Okay, okay. So,
Ahead.
wait,
So moving
sorry,
on.
sorry everybody. Can you like send me a request to I can't find the recording this thing. Send me a request to start recording so that okay, I've seen it.
That's
Uh,
it. Okay.
yes. Record
So we are
start.
the selector switch.
Yeah.
So we stopped at the selector switch where I'm talking about someone asked in the group, on the group or in my DM that why can't we use three-state selector switch? For me, why I wouldn't use three-state selector switch is because we already have a switch here doing the on and off command. So this is just supposed to change the mode from either manual or auto. This is not supposed to serve as a switch for turning it off. This is just supposed to select, okay, well, we want to run on manual or we want to run on auto. So this is how the sequence for manual and auto is working. So this K3 here is the relay from this place, this K3, this 24-volt relay, the small relay. So that's what I use here. So what happens is whenever the ultrasonic sensor senses that okay, the water is filled, it sends signal. I mean the water is not filled, it sends signal, this guy closes, then it keeps pumping. So far the switch is being pressed, it has been pressed already. Then it keep pumping until when this guy opens again. But when you're on manual mode, it bypass this switch. This sensor, sorry, the ultrasonic sensor, it bypasses it. It just keeps sending signal to the switch. As far as the on push button has been done, then it keeps sending signal to it to pump until you come and off it manually before the pump goes off. Then these are indicators. Sorry, I didn't label mine. So it's supposed to be okay. This is for on manual mode, and this is for running. Then I think that is that on this side. So the main Sorry, are we together? Are we still together? Let me get reactions. Try move further. I can't see any reaction. Okay. Think you are good. Yes. Okay. So the main topic for today is how to, from this your layout, generate your 3D panel. So that's why I created. Let me start sharing this. Hold on. That's why I created this for my design. Please let's verify that we can see the screen I'm sharing now. Can we see? Okay, yes, we can see it. So for my own panel, these are all the components I have in my panel. So what I did was, yes, this is the standard to go by. Yeah, what I did was give all the components, lay them out on an Excel sheet. Each component, the weight, the height, and the depth of each component, where they will be located on the panel. Is it the top, the middle, or the bottom part of the panel? So we have a main isolator, which was I explained while we are using that in the layout space. We have the main isolator that will be in the middle. Then we have an MCCB or MCB for the power side that will be on top. So just note the weight and the height. This is the two major things that we need. Now we are trying to select the size of our panel that we'll be using for this project. I hope some people are also doing the same thing on their end. So if you have some of these components in your design, you can as well just pick them and then start writing in a paper or something to do your calculation. Because I would love to see at least one or two persons panel at the end of the session today. So are we together? Okay. So we have contactor, AC contactor for the motor 1, then the weight, the height, and the depth. Then we have MPCB for the motor also, the weight, height, and depth. On terminal blocks, we have that also. 24 volts power supply is stated out. The control MCB, that's for the 24 volts. We've also laid it out, and the weight, height, and depth have been analyzed also. Then moving forward, we have a control relay. This is the small relay that we use for the ultrasonic sensor. So we have that also stated out here. More device, the 24-volt distributor stated out, the control terminal blocks and all of that. And this was for the panel. As you can see, we have the stop push button, start push button, selector, so indicator lamp, and all of that. So we'll go to the enclosure sizing part now. Okay. So for the top margin, which is the topmost part of the panel, so before you go ahead to say you want to build a panel, after you've analyzed all your components in the panel, then you visualize which one is the power, which one is the control, which one am I placing up, which am I placing in the middle, or which am I placing down. It's non-negotiable that your terminal block will be down because all the control cable, power cable coming in, you connect them down. You can do up feed or down feed or even side feed, either ways, either one that you want to go with. But I'm doing down feed here, so my terminal blocks will be the lowest part of the drawing. So I did something like this here. So I hope you can see this. This is what I hope my panel would look like. So from visualizing it, these are my these are my cable dots. This green part, wait. So this is the cable dot here, this green part, this one. Then this is to represent my DIN rail. This. The three is to represent my DIN rail. So this is the topmost part. Let's now go to the chart to check what is supposed to be on the topmost part. For the topmost part of the panel, we are to have this, which is the MCCB. What is the height of the MCCB? We have 70. We will not write that 70 down. We'll look at it that, okay, do we have anything bigger than 70? Because we're looking at height here. We're not summing, how will I put it? We're not summing the height straight down like this. We're looking at the height for just the topmost part. So we'll look for what is the tallest component that we're having up there. So moving forward, we'll look at it again. What else do we have on top? We have MPCB. This is for the motor. Which height is what? 100. Is it the highest? Is it the tallest or tallest of the component? No. You come down to the 24-volt DC power supply with the height of 125. I think that is the highest stuff we have in the panel. So the enclosure sizing, you put it here. PSU power supply is 124, tallest power component. Then remember in our last class, we talked about column gap, the tolerance you leave between this, hold on, this place and this place. That I said the minimum you can do is 100 and the maximum standard is 150. So we're using 150 because we have a component that of height of 125. So we're using 150 there. So the column gap will be what? 150. Then we have cable dot. So look at this. We have what? this cable dot here, we are using 30 cable dot. So we have 30 up here and 30 down here. So 30 plus 30 will give us 60. So for the topmost part, we have 335. We have 335 for the topmost part. Then for the middle section, what do we have that is the tallest? So we'll come here, we'll check. For the middle, we have the height of 85 for the contactor. Then in the middle, we have the height of 150. No. This one is in the middle, yes. For that, we have the height of 150. Then for this, what's this guy? What's this part again? We have the height of 70. So we'll be going with this contactor. So if we're having this now, the sum of the 5 components plus the 15 gap. So on the DIN ratio, if you remember from the last class, I explained that your DIN ratio should always have at least 20% gap for, what is this thing called? You should leave room for expansion. So this part, we're looking at this part now. This part of the panel, this part. So now we're looking at the contactor. The height of the contactor is what? 85. Then the column gap we're using 100. So why are we not using 150? The component we have here, the tall component we have here is not up to 125. We don't have a component as tall as 125 in the middle here, so we'll go for what? 100. Going for 150 would not is not, how will I put it? What of terminal isolator? I don't get what the person means by terminal isolator. Hold on, let me check that. Sorry. Yeah, we don't have terminal isolator here, so okay. So moving on. We have this 85 here. Then the gap we're leaving in between is what? 100. Then cable dot. Since we've calculated for this one and this one before, which is 60, we're only calculating for this one here, another 30. So we'd have 30 there. For that middle height, we're having what? 215. Then from the lowest part of the drawing, which is this part, what do we have there? We just have terminal block, and the height of it is what? 100. Then we leave a column gap of 100, which is the minimum acceptable. Then your cable dot is what? 30. Then this cable dot down here, since we've calculated this one for this middle part before, just calculate this one, then 30. So that's what? 2, 230. So we'll do 3, let's do it here, 315 plus 215 plus this, give us what? 780. I think there are some questions in the chat. That all the columns should have equal gap. It's not like it's not mandatory that all the columns should not have equal gap. The maximum, please hope this file will be sent to us. I'll think about it. So it's not like it's not mandatory that all the gap, we could as well use 150 here. We've used 150 up here. We can use 150 here too, and 150 down here. But the main reason why I'm choosing 150 here up here is because of the isolator, where the power supply unit we have there. The power supply unit is quite 125, and if you are using 100 and 125, the cable, the tolerance for you to wire into the power supply unit will be small. That's why I'm looking at 150. So the minimum you can use is 100. The maximum you can use is 150. You can as well choose to use 125. In this same design, I can as well say, okay, I'm not using 100, I'm using 125 for the middle part. So it's a thing of choice. But the minimum and maximum is 150 and 100. So we had 780. The closest, I don't know, are we still together? I think we're still together. Yes. Okay. So the closest standard, we're rounding it up to the standard enclosure size, which is 800. So that, remember in the last class, I said you don't round down. if you are trying to get an enclosure size, you round up. I think I finished. So then, oh, for the width of the panel, we'll come back here to our component schedule. We'll look at the top part of the component because that's where we have major and big component there. Then we'll go to the DC power supply. What's the width? We have 125. We have 125. Then we'll come back here. We also have what again in the topmost part? We have uh MCCB or this, we have 75. So let's come here and do 125 plus 75. Do this in the calculation form. So we have the topmost part. So we have 75. We also have what? 125. What else do we have there? We have 75 again for the control MCB. Then for the topmost part again, what else do we have? We have 60. So we are using 75 again and no, sorry, I was looking at the height for this instead of the width. Sorry, there's some question. Please, I'm not understanding this sizing. Please, how do you get 60 for cable dot height for top? Okay, so how I got 60 here? How I got 60 here is because we are using a 30 cable dot. So this is 30 here. This O cable dot here like this. Sorry. This O cable dot here is 30 The one in the middle also here is 30 So 30 plus 30 is what? 60. So what we're looking is 30 plus 30, 60. I don't know if that's okay. Then please, I'm not understanding this sizing. So this sizing, what I did to get my own size was, look, I gave ChatGPT the whole component I'm using. Help me generate a size chart for this. So the main isolator you're asking of it to be in the middle. We factor that in already. The main isolator will be in the middle. Boluwatife. The main isolator will be in the middle. You'll see it in the drawing very soon. So I think we can move on. We're looking at the width of the panel now. So for the topmost part, which has majorly all the big components, we have 125. You put your 125 here is equals to 125. Then you come back here again. Which other component do we have on the top shelf? We have this, we have 75 plus 75. Which other component do we have here? We have 60, the MPCB. Okay. Plus 60. Which other component do we have here for the top? Okay. We also have another 75 for the control MPCB. Then we have plus 75. So the total is what? 335. So remember, for the weight, so if we are using this now, what you just calculated is you put this one, you put your power supply unit, immediately you put your power supply unit, you put your MPCB by the side, you put this one. So we didn't put any tolerance. And in our last class, we talked about a 20% tolerance on your D-ray. I don't know if anybody is still active with me. We talked about 20% tolerance on your D-ray. So what you do is equals to this times 0.2. I think we all know why I'm using 0.2. 20% is 0.2. That's 20 divided by 100, 0.2. So you multiply it, you get what? 67. So what you do is this is equals to 67 plus, I mean 335 plus 67. So if you have any question or you don't have any, you don't understand any part of it, you can always drop it in the chat box. I'm looking at it too. We can always move back. I don't want at the end of the class anybody does not understand. what we are doing here. So we have 402. So the closest standard to 402 is what? So from this now, we already have our panel to be 400 by 800 by 250. Why am I using 250? I know some people would ask. Look at I don't understand the calculation. You don't understand the calculation. So let's go back to, let's just, me too, okay. Please pay attention now. Let's just look at it once more. So I said for your panel, the first thing to do is get the dimension of all your components. Get all the components, all the dimension you need for all the components. This sizing. For the sizing, how I got the sizing is I don't need to go on Google to search for, okay, I want sizing for this, I want sizing for that, I want sizing for this. So what you just need to do is go to ChatGPT or Claude AI, whichever AI you're making use of, put in all your components and ask it to give you size, dimension for all these components. It will give you everything. Then you can populate it into an Excel format. So for this, for the top layer, this part of the panel, the top layer, I said, what is the tallest component we have there? The tallest component we have there is the DC power supply, which is 125. So that's why we're having 125 here. You know, we're trying to calculate, hold on. We're trying to calculate height. Let's see what we're trying to calculate now is from here to here. I don't know if you can see what I'm marking. We're trying to calculate from here to here, from this top place to this down place. So if you are trying to calculate from this place to this place now, and the tallest component you have there is what? 125. If 125 is here, you cannot add another. So we'll get to that 20% again. So for the component, for the height now, we're looking at size from here to here. Size from what? Here to here. So if you are having one, the power, how do you know where the component was supposed to be on the panel? The last class we mentioned it that you section your component. Different companies have different standard, and different people also have different standard. But at the end of the day, the whole what it all boils down to is that your control components are specially separated from your power component. They are not jam-packed or wired together. So the topmost layer is not for only power component. You might work in some panel building component and they would say, okay, what they want is all their control devices, contactor, everything should be up, or what they want is all their drive should be up. They have their reason. But as far as your drive is up, your power is in another place. It's not that you're having drive and power up, you're having this one, you're having what's this thing called? Your control and power components up in the same place. So you are good to go. Then let's move forward. I said why I'm using 125 is because we're trying to calculate the height from here to this place. The height from here to this place, that's what we're trying to calculate. So the 125 is the tallest component we have there. And if you are trying to calculate for height here, you look at the tallest component. You are not looking at all the components there. You will not add all the components because it's height you are looking at. So you calculate for only the tallest component. And the tallest component we have that will stay up is what? Our power supply unit. And our power supply unit is what? 125. Then we talked about the column gap. We talked about the column gap. We talk about the column gap. The column gap is what? 150. Where is it? Okay. The column gap here, 150. I explained that in the last class that for standard of panel building, you have to leave a space of 150 in between your D-ray. But the minimum acceptable is what? 100 mm. If you can't leave 150, you have to leave at least 100 mm. So now we're leaving 150 because we have a very tall component. If you have drives in there, drives is up to 200 in terms of height. If you are using, what's this guy called? the downforce drives up to 200. So those kind of components, you know you are leaving 200 or 150 mm, because that 150 mm will be enough for you to bend your cable in any radius to terminate on the component we are talking about. Because these components are big and they are protruding, they come out like the depth is much compared to other components. So let's move forward. We have 125. That's why I'm using 125 here. Then 150 for the tolerance because of the way the component is. I'm using 150 here and here. Then we also have cable dot 60. Why I said cable dot is 60 is we have 30 up here and we have 30 down here. Since we are calculating for the height, so now I've added from this part to this part. Now that's what I'm calculating for, which is already what? 135. So from this part to this part is expected to be 135. So now we're moving to the middle part. So for the middle part, we have a contactor, which is the tallest component in that middle part. Then for the contactor, it will be easier. Then we have other component also there. So since we have contactor only as the tallest component, so while leaving 150 space there is not bad according to standard. But looking at your panel, the cable would how will I put it? Your cable will be showing too much if you are putting 150 gap there. Your cable would have to extend before it gets to the contactor. But leaving 100 gap is suitable for that kind of situation. So we are going with 100. We have colon 185 plus what? 100, that's 185. Then for the cable dot, since if you remember, we said we've calculated from this part to this part to be 335. Then now we're calculating from this part, which is 50, because I said the column gap is what? 100. So that's 50, 50, like the middle, the column gap. 50, 50, 50, 50. So that's 50, 50, that's 100 plus, what's the equipment? 85. That's 85. 85 plus 100, 185. Then we're adding this to it, which is 30. That's 215. That's how I got 215. So now we've calculated from up here to this part of the panel. So now let's calculate the down part of the panel. So what is in the lowest part of the panel is what? A terminal block. The height of the terminal block is what? 100. So if you are looking at, God, if you are looking at the terminal block now for 100, we look at it that, okay, it's only 100 that you have here. Then 85, 85 mm, 85 mm, that's the size of the contactor. So then for the terminal block, we have 100 here. How will I put it? Yeah, for the terminal block, we have 100 here. So we've calculated from this top part to this part now. So we want to calculate for the terminal block 100 in the middle. So since we have 100, then the column gap, we're also making use of 100. That's 50, 50. So terminal block in this middle is 100. 50, 50, that's 200. Since we stopped at this place before, we'll just add this 30 for the lower part to it. That will give us 230. Then what we did is we add this one plus this one plus this one. It will No, 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 no. Contactors differ. Size of contactors differ. We have 330. I've seen contactors that use 330. I've seen the one that use single phase. Like in terms, I'm talking in terms of coil power now to power their coil, because contactor size differs with respect to their coil size. So this is 5 mm now is for the small type, the one we're using for the motor now. Even the small type for the motor also differs. We have the Siemens on this type. We have We have the Siemens one that are just small, small type that does not allow you to slot on it. So I'll show you that in the 3D layout space. So then we'll add this plus this and then this. So that's how we add 780. So the closest standard to 780, because you won't see 780 in the panel layout. I think what we can see there is 760 or so or thereabout. So I said we shouldn't round up, we shouldn't round down. Round down, we should round up. So the closest to it is what? 800. So for the width that we were measuring before, from here, yes, 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 I agree with that. So it's Siemens are making use of. So for the width from here downward to this other side, that's what we're trying to measure now. So we'll look at the topmost part again. If you want to measure the width, you look at it that, okay, which part of my panel has more component? And for me, has more component and their width is bigger. For me, I'll go back to my stuff. I'll check, okay, which width I have 100 here, I have 100. The largest width I have here now is what? 125, which is also from the topmost layer. So we'll go with the topmost layer. On the roundup, I said we had, what was our total calculation? 780. 780 is the total calculation if you add this plus this plus this. That's 780. But we don't round down in panel building. So round down means, okay, you are not going for 750 or 730. So you ramp up to the closest, is it whole number or there, but then you go with 800. So that's why we chose 800 for the height of the panel. Then let's go to the next one. We have the control. Okay. So for the next part of the panel, we have the width. We want to measure the width now. So for the width, we have what's the tallest one? We have the widest component we have there, 125. 125 mm. So if we are picking 125 mm, so let's assume we already have 125 mm. So the 125 mm will be, let's say, from here to here, 125 mm for the power supply unit. Then which other component do we have that is on top again? 75 mm. Come back to this space. Let's say we're adding another 75 mm is there. Then which other component do we have on top again? We have 60. Please mute your mic code. Let's cooperate. We have 60, so we can add the 60 also. Let's add the 60 up here. Then which other component do we have on top again in terms of width? So we've used 75, okay. 75, 125, 60, and 75. So that was what we did here. That was what we did here. If you look at this page, 125 plus 75 plus 60 plus 75. That was how we got the 335. So and I said, remember, that was where the 20% the other person was asking comments. Do you remember that 20% on the what we just calculated was this one 125, this one 75, this one 60, this one so is the total sum, the accurate sum that we calculated. So we've not leave room for buffer or room for expansion. That's why we now do 20% of the whole calculation, which is 335 times 0.2. 0.2 is 20%, so that gave us what 67. We now do 335 plus 67, we have 402. The closest to 402 in terms of panel choosing is 400. You can't go for 415 or 430. So you go for 400, then you put the 400 back here. Then I'm talking about the depth now. I'm using the depth of 215, 250. I know someone might ask why, so let me go there. So the what's this thing called? The component with the largest depth that we have here now is what? 100. So the highest that the component will come out is what? 100 mm. That's why we already have 100 like that. Then remember, we have, what are these things called again? These 90 mm, the push button that will be on the door, emergency buttons, all of this that will be on the door. They are facing opposite side, so they are also pushing inside. And if we have 100 mm and we have 90 mm, that's already over 200. And if you do not leave tolerance gap between them, it should just be rubbing on the surface of, what's this guy called? On the surface of the power supply unit. So, and size for the standard depth for small enclosure mostly is 205, 250. Mostly you will see the one of lower depending on your calculation. So based on this calculation now, we have 190. If I said I want to go ahead and choose 205 or 240, it will work. But I'm going for 250 because of personal preference, and we'll be adding fan on what this guy called again. We'll be adding side fan to it. I don't know, let me see if I can show you that in this 3D layout. I'll move on. We'll be adding this. Sorry. So we'll be adding this to it. This. So if we're adding this fan to it for cross ventilation, so it's for the whole enclosure. It's for the whole enclosure, not just the mounting plate. So for this side now, because we're adding this fan to it, that's why the depth will have because this fan, if you look inside it, it also has what's this thing called? It also has some components where the main fan is. This is just the vent for the fan to blow out. So let's go back to the Excel. Okay. Oh, let's go back to the Excel first. So from our calculation, this is what we later agreed on for the panel. We are using 400 by 800 by 250. So if you want to start your panel drawing in EPLAN, you go to Rita. Let's go to Chrome. Now what? Don't mind my. It's okay, I'm not showing my Euclid. Don't see us just display. Yeah, okay. Let me share the Chrome screen. Okay. So you go to Google Chrome or whichever browser you're making use of, add Rita Enclosure. So to save yourself the stress of having to scroll to over 1,000 catalog of panel that Rita has, like I always say, engineers are meant to be smart and time conscious. So what I would do in that situation is take this, you go to your ChatGPT, you take the Excel calculation. So you are still on the Chrome, so I know. You take the Excel calculation, which is the 400 by 800 by 250. Then, hold on. Let me share the ChatGPT part. Then you go to ChatGPT. I think you can see yes, you go to ChatGPT, give me a Rita part number for the enclosure specification, then you put the enclosure specification. For Rita part number, then it will give you enclosure specification for what you just paste. So if you can see the screen, please let me have reactions in the comment or something so I can know that we are together. So instead of going to search on Rita sorry, I don't know, can you see the screen, please? The ChatGPT part. Okay, you can see it. Okay. So you see the enclosure to give you a part number for the enclosure. Look at what we have now. So we already have a part number for the enclosure. Instead of having to go there and start searching for the component, the panel you need, you just take the part number. Then let me share the Chrome part again. So you go back to Chrome, then you put in your part number and click on search. Voila. So you have your panel here. This is your panel, IP66, depending on where you want to put it. Either there's water, because for these settings now, since we're already talking from what I gave you as the assignment, I said what a pumping system. So definitely there will be water close to where the um, system might be, except stated in the question that, okay, there will be a room for the panel or it will be placed somewhere close or something. So IP66 is always your go-to. Then, upon arrival here, you scroll down to your what? To your card. So from your card, you click on direct download. What you want to download now is not EDZ. You are downloading the step file. You are downloading the what step file, 3D module. You click on it. Then level of detail, high level with extrusion layer. Then you request download. Sorry. Okay. Please, let's avoid drawing on my screen, please. So we're back here now. Then you click on your download. Then you start downloading. So after the download is complete, let's go back to EPLAN. So this was the fund I was making mention of the other time. Yes, this was the fund I was making mention of the other time. So now you're in EPLAN. If you check the topmost part of your EPLAN, you have page, you have layout, then you have device and tool. So you go to layout. Then on your layout space, let me close all of it. You click on file, import, layout space, step file. So I've already downloaded the step file before, so I'll just click on it, then open. So if you remember during our last class, I was saying something about you rotate angle 90, you do this at angle 90. You see that, okay, so this is the panel. The panel we selected there. We've brought it to EPLAN module. So on your EPLAN module now, what do? You want to make the panel, because if you look at it now, go to your view and click on front view. Look at what it will be showing you. The panel is supposed to be standing, so you can see the whole component and everything, the way it's supposed to operate. So what you do is, let me see the way it came in. Okay. What you do is highlight the whole panel, go to edit. Once you get to edit, that's how I'm not moving fast though, so you can all see what I'm doing. Rotate around axis, then you zoom in. You see there's a white yellow line coming up. You see it. Once the yellow line comes on, you click on it. Once you click on it, look at what is saying down here. Down in this place, specify direction of rotation. So if you want to specify direction, which angle do you want to rotate it to? Is it this side? Is it this side or this side? So I want it to rotate towards this side. You click on this side. So most digital panel, once you import it, just use this angle here that I'm using now. Then use angle what it said, enter rotation angle 90 degrees. Then click enter. So what do we have? Our panel is standing well and ready to go. So now if you click on view, front view, it will give you the original front view we're supposed to have. Okay. So moving forward, this is the one we just downloaded now. So what you do next is you look for the mounting plate. You see, this is just the enclosure. This is just this is the door. This is the lock. This is the lock again. This is the base. Then this is our guy. This is what the mounting plate. So what do? You change the view to front view. You cannot see my cursor. You see where I'm pointing to. Take it to what? Front view. So when you get to the front view layout of it, then you what? You declare, hold on please, I need to close this back. Okay. When you get to the front view, you would go to what? Insert, mounting surface. So you declare it as a mounting surface. Select it. Okay. So you declare it as a mounting surface. Then if you use AutoCAD, well, you see it has showed there that what we have a mounting surface. You know, AutoCAD don't select something to release the stuff. You just click on escape on your keyboard, escape. So you go back to you having only your cursor. So now this page is a mounting page, mounting surface. So let me show you what will happen if we don't have a mounting surface there. So I've deleted the mounting surface. This is just it. Look at what would happen. This is where you pick your cable dots. You see, because you don't have a mounting surface, If you are trying to click on cable dot, it won't appear. It will assume, okay, where do you want to put the cable dot? There's no mounting surface. But after we declare our mounting surface now, once we declare this part as our mounting surface, then we click on escape. Now let's go back to click on this and see what will happen. You see, it will open up to us to select which cable dot we want to make use of. So from the selection, you can see we have different cable dot sizes. We have 30 by 2000 by 80. We have what 60 by 2000 by 80, and we have 80 by 2000. And remember in our Excel sheet, we said we are using making use of 30. Then you double click it on this. Then you come down to this part, you leave gap, and you do this. You do the same thing down here, and you do this. So I always prefer to first do my whole box like rectangle like cable dot design, and do this. Then you can move this to the edge. So you can also do the same thing for this one. Move it to the edge. Then edit. You come here, change length. You click on it, increase the length. Click on it, increase the length. So we have suitable length for this, and this now. So moving forward, from our layout in Excel, we said we have what 3 sides, like three rows, 1, 2, and 3 in the last part. So for the top part, you have to insert your what? Your DIN rail. So you go come back here, mounting rail, mounting rail. I hope some people are also doing the same thing in their EPLAN. So then you place your mounting rail down here. So we've placed the mounting rail. Now let's go back. Let's look at what we have that we said we'll put on the top. Hold on. So all the cable dot are not imported, if they came with EPLAN. So you just see them in your insert. Once you get to your layout space, you see them at insert part. I want to select what I want to see. Okay. Now let's go back to our Excel and look at what we said will be on the top part of the panel. For the top, we said we have the MPCB, the motor potential circuit breaker. So we would have that on the top part of the panel. Then we also have what again? MCCB. That's for the power protection, and also MCCB for the, what's this guy called? 24-volt protection. Then we also have our what? Our 24-volt DC power supply. So you come down here and then you come here. So first of all, we want to add our, okay, I think I'm not yet sharing this EPLAN layout. Yes, okay. So we're back at the EPLAN layout. So we want to add, oh, what is this guy called now? We want to add the motor MPCB. So you can come here, put MPCB. It will bring this out. But we're not using this. What we're using is Siemens MPCB. So let's go to Siemens portal to download our MPCB. So you go to Chrome. So all of these components, as far as you can get their step file, they are good to go. So I'm trying to share my Chrome screen again. Okay. So you go back to Chrome, click here and say Siemens. Sorry. MPCB. Yes, since you've seen one Siemens MPCB, look at the one we are making use of for the purpose of the drawing. So what we need here is just the part number. So what we need here is just the part number. You come here, copy the part number. This is the part number for it. Copy the part number. As you can see, this is the guy. Then you now click back here. You go to Siemens Industrial More. Industrial Support Siemens. So for you to be able to use this, what is this thing called? Industrial More, you have to log in or create account with them. Since I already have an account with them, I'll just sign in my account. Think I'm good to go that way. So after signing in, the part number we copied before, come here and paste your part number. Then you click on search. So after searching, I already downloaded all this component. I'm just trying to show us how to download it. Go to cast data. 3D module. You look around there, we're looking for the STP file, the step file. Look at this. This is a step file. This is a JPEG, PDF, JPEG. So we go to the step file. Then it's downloading already. It's done downloading. So the same method we used to import that panel. Why are we using Siemens? It differs. I would say for me, why I'm making use of Siemens is because the company I work with, we're heavy on Siemens products. Heavy in the sense that we make use of Siemens for almost all our panel, both the HMI IDs. So we only go to Schneider whenever we're building what is this thing called? A big power panel or thereabout. So we're heavy on Siemens. That's why I'm accustomed to Siemens. So you can also use, in case you want to use Schneider or any other one, just go to their website, look for the step file. That's all you need. So let's go back to EPLAN. Since we've downloaded that guy, we'll still come back to EPLAN. Yeah, file, import, sorry, layout space, then file, import, layout space, step file. Then you go to your download, the one I just downloaded this night. Sorry, I want to just pick this cover. Yeah, sorry about that. So I think we're back. Then after you downloaded this guy, what you do is go to your view, rotate, insert, you define. You can see the process defined. So one thing about 3D module is it has a lot of process, but you get accustomed to it the more you use them. So you might forget, okay, how did I go about this part? But when you start drawing by yourself, you would be forced to, okay, go and make research. How did I do it? You now say, oh, this was what I did. And one thing how will I put it? I know is that what you learn by yourself from your research is always hard to forget. That's one thing I've noticed. Like maybe one thing you need to learn, you have to go extra mile. Then you define your mountain surface also. So this back is the mountain surface we are using. You click on it, you define it. Okay. So after doing that, escape, then you just copy it. So we'll now go back to where we were building our panel before. So we'll paste it here. As you can see, as simple as that. So the tagging and all of that is after you are done drawing, then you click on it and then make sure the name tallies. So we also said we will have our power supply module here. So EPLAN has some power supply module, but let me see. If you want to check EPLAN, I already downloaded some. So component, voltage generation, general, SC is Siemens, then you see EPLAN has some power supply module. You just drag it out. But most of the time, what you get is just the block format, not the real detailed drawing. I'm trying to see, hey, look at this. Look at what EPLAN is giving you. Just the block form, not the real detailed drawing. So to get the real detailed drawing, we'll go back to Siemens and have to go through that process again. So it's the same thing. So, but I already have it downloaded here to save us time. Sorry. I already have, look at it here. So I already have it downloaded. This is a setup module, a 230-volt input and 24-volt output module. So as I did before, view, you go to view, rotate. I already did all of that for this before. So you then insert, you define the back, select handle, this is the handle. You done that also, then mounting surface, this is the mounting surface. So yeah, mounting surface already has it. So you just do okay. Then you copy it again. Control C. Then we'll go back to our panel. So this is our panel. We'll come back here. We'll click on Control V. And place it here. So what do you notice? Because of the height of this guy, there's no space up again here. So what will we do? You move this guy upward. Then you just come here, edit, change length, sweet as that, change the length, change length, perfect. So this is the setup module for it again. Then after that, what do we have up again? We have two breakers up. So you can just come here, just say MCCB, open it, or we're using MCB because of the power, not this, not this, not this. So let's go to device. So EPLAN already have some of these components. Instead of always downloading, you can just come here and then look for the one you want. Sorry, please let's mute our mic. We can use the chat box to communicate. Trying to look for a double pole breaker. Someone is still trying
My
to
mother
speak.
is worse than oh,
Oh, Alfred, please.
uh, I just was supposed to yeah,
Not this, please. I don't want us to go and start downloading the guy again. Since humans already have it. I'm sure I've seen it somewhere here before. This are not. You can see different components that they have there. Even auxiliary contact for your this guy, even this relay. No, I've seen it somewhere before. I don't know. Hold on, please. So let's see. Okay, exactly. This is the guy. So you know there are miniature circuit breaker. So if you are using MCCB, that's modeled case circuit breaker. Those are the big type that are referred to as a big boy. So you put one here for the purpose of this, then escape. So we're done with the top part. You come back to your insert, pick your cable dot again. Then leave your gap between it. Hold on. So why those words were showing before is because this was turned on. Invisible element is trying to show you what details about the component. This was wire dot, Rita panel, this and that. So and all of that will convince you when drawing. So you can just always hide them. Even the mounting aid, you can always hide them to just to make you see what you're doing. Then moving forward, we put a gap between them. We go back to insert again, put another DIN rail, mounting rail. I know it's stressful, but at least step by step, you would definitely get it. So this middle now, all the way I agree that will be in the middle. Let me check the Excel sheet. So we're having this one here for the 24 volts. Yep. Then we're also having a more device. The more device is the distributor I mentioned. This is it here. This is the more device I'm talking about, this one. So we would have to put it also. So we've added this one. This is the one that is in the topmost part. This is the 24 volt, the 230 to 24 volt converter. So we'll go back to our layout space. Come here, escape. Yeah, because I've downloaded it before, if you do MURL, you will find it in my this thing. But for people who have not downloaded it before, we'll go back to your Chrome. Where is my Chrome? Go back to your Chrome. I'm just trying to do this just to make us know that there's no component you are looking for that you can't find online as far as you know their location. So this is their website, RR. Ma 24-volt power supply distributor. Then you look for the one you want to make use of. For the purpose of this training, we are making use of, where's the guy? Let's go to this more electronics. Scroll. I think is it here. Not this guy. Let's go to image. This is the one that I'm making use of. This guy. Can just copy the part number also. There's no hard feeling. Then we'll go back to their website. This is their website here. More electronics. Input the part number there. It will bring it out for you. This is it. Then you click on the product. Then scroll down to download. Under download, you see where they put P8. P8 means like EPLAN electrical 8 or something. So this is P8. The zip file. Then what you do is just download the zip file. So if you are downloading the zip file now, you're downloading the EDZ format. Yeah, I agree. Then download. I don't think this one needs you to sign in. So you just download the EDZ file, which I already did. So we'll go back to our EPLAN. You go to you know how to import your EDZ, master data, management. I've not extracted it though. This one I just download. So you come to this, you go and extract it first of all. I don't know, we all know how to extract now. We've extracted it here, yes to all. So come here, import, then come here. Look for the one that I just downloaded. I already have downloaded it before. This is here, EDZ of it, and you just import the EDZ. Okay, yes to all. Then you cancel. So since you have the EDZ ready, you can also search it now on your search bar. You will get the 3D model. So you just bring it, drag it out, and drop it. So if you are working with it now, if you can see it in your 3D model, let me know in the chat. If not, you should know what the problem is. We can also import it as step 5, but it's always easier to do this one this way. I won't advise you import it as step 5. So what else do we want to have in the middle layer? I think we've had this and this. Let me go back to the Excel cheat sheet to see what else we want to have there. Where's my Excel? Okay. Yeah, contactor. We've now added the contactor. We've added the NCBB. Now added the contactor, the control relay. Okay, we've added the manual device and just the contactor and the control relay. So since we already have this here, we'll move it a little bit. Without forgetting about the gap we want to put. Then we'll go and look for our contactor. I already downloaded all of this, so contactor. See, this is the one I'm saying that the sizes differ. This one size is different from this one size is different from this is an auxiliary contactor. This is not even the one I'm trying to show you. It's different from this one size. It's different from this one size. So I already downloaded the. Let me see if I still have it here. Yeah. So I've already downloaded the contactor I'm using before. This is the Siemens contactor type I'm making use of. This type is the one I'm talking about. Like I said, this one size is also different from that other one size that we have there. So what you do again, the same process, just view, rotate, escape, insert, define the back, then undo, Select this middle as the handle. Then mounting surface. Select the mounting surface for it also. Okay, then you copy. Ctrl C. Then now after copying, you go back to your design. So how I got this was the same process. Go to Siemens, click on search for contactor, download the step file for it on Siemens, the 3D card module. Download the step file, then you import it. So once you get back here to your drawing space, so where are we? Control V. This is our guy. Then you put him here. Pen. We're almost done. So after placing your contactor down there, what's next? We also agreed that we're going to put a control relay. Let me show you where the control relay is coming from before. This relay we're making use of here. This relay here. So I'm not using contactor. I'm making use of the control relay, which I already downloaded also. So to download this also is a Siemens relay I'm making use of. This is it here. This is the relay I'm making use of. I hope we all know this type of relay, the one that you can change the. These are just the normal basic relay, A1, A2, then normally close or normally open. It's not the type used for switching big heavy load. That's the main difference between relay and contactor also though. So you do the same process, view, rotate, escape. So the amount of time I've done this today, we should already at least be grabbing one or two about on how to import and put on your drawing space. Then you define your handle, your mounting surface, which is this. You define it also, okay. Then escape, then you copy. Ctrl C. Now let's go back to our drawing. Ctrl V. Let's put it here. So what next? Insert, view, cable dot. And you can also, instead of this insert all the time I'm going here, I'll do something for the next cable dot we want to bring in now. Just enter, okay, since it's still 30 we're using, that's okay. So then we're coming down here again. Didn't real. Okay. So what do we agree that will be here? We agree that we'll put our terminal blocks down here. So the terminal block, the power input will come in from here. Will come in from our isolator. Then it goes to the terminal block. From the terminal block goes up and all of that. So you can just click on this part. You say, imagine someone's already asking me that I attended today's class but couldn't mark attendance due to network going on. And we're not done with the class. Great Nigerian students. So click on connection. A big connection here, I think. Yeah, so these are the different terminal block you can make use of. We have this type. This is for PE. We'll make use of that also. So you bring this in. You place it here. You can zoom in now. So since they are terminal block, you won't want to leave too much gap. So we're having 4 here first for input to the, what's this guy called? the main input, like live, line 1, line 2, line 3, and neutral. Then we're having another one, let's say for our controls, 1, 2, let's just put as many as we can. So, but this you should know the number of terminal block you're making use of. I made use of some terminal block in the drawing. Maybe I'll go back to that and show us. Just keep dropping it as many as you want to. Then for the P, just pick your P, place it here. Let's say we're using up to 2, place it here. So to tag your terminal blocks, you know, incoming components, let's go in here. I want to give the terminal end clamp. So we have this end clamp. We have worked with panel, you know, this end clamp just to segment, okay, this one is different from this one. This one is not this one, so you don't mix it up. Segment this guy, and segment this other big guy here. And you can also make use of partitions, very small partition. In case of your design, you want to just put space in between, just put your partition there. Put your partition, put it anywhere. You can also make use of that. So moving on, I think this is okay. This is not all. We should not forget our, most I don't add this, but for the sake of this class, I would want us to add this. So I want this to serve as our health bar. So if you are building panel, you should always leave room for your health bar down on the panel. Most places it might not be on the panel plate, I be on the mounting plate, it should be on the main panel ground. So for the sake of this, I want us to put it on this part. Then go back and pick this. These are just like the connection clip or something. 1, 2, 3, 4. So let's view from side view because it's already looking like we're doing magic. So you're looking at it from your side, you can see the 3D model. This is our panel, this is this is this. This is our relay contactor partition that we added for this. This is our earthing bar. This is where, okay, you have from this terminal block, you put it directly on the earthing bar. Then in case any comma to, you put it here. So all these has their earth would mount them there. Please let me know if we're still together. Sorry. Wow. Okay. Sorry, yeah, sorry, are we? What's the size of the terminal block in the alignment with the cable that you carry? Okay, so sizes of terminal block, we're putting this here just for reference purpose. Sizes of terminal blocks differs. We have terminal block for power input like the AC. We have terminal block for controls, those one that we use for the control cable, those small ones. So these small ones that are here now are for the small small. If you want those big terminal block, we'll download it, the ADZ also, and then put it there. You can make use of LU cable or anyone. So coming. So that's how we got this. So moving on, let me check. Let's now go to the main enclosure. So you see, you notice that this is no more there again like this now. This is no more there. So you can just do, if you want to see what's inside, you just do this, right click, then hide. So you see inside your enclosure, kuro kuro. You can see inside the enclosure. So now I want to go to the enclosure door and add component to the enclosure door. So for the enclosure door, we are going to put a selector switch, an emergency button, and what else? Selector switch, emergency button, and indicators. Whew. So let's look for the, sorry. Okay. So this is it. Let's look for, you come here and look for the door again. So can we still hear me, please? Let me know in the chat box if you can still hear me. So this is the door. If you can still hear me, just say yes in the chat box. This is the door now. Okay, thank you. So this is the door. So for the door, what do we do? We said we are going to add um no, registering with Siemens is free. You are not paying any money to register with Siemens. You are not registering with, you are creating an account on their website, that's Siemens Industrial Mall. It's not like you're registering with Siemens directly as their partner. You're just creating an account. It's just like creating social media accounts. So you just put your email and password. So that way all your components, you can have them in one place, all the one you downloaded before. So you can always go back to check them. So that's it too. So now let's come back here. Let's come back here. Indicator. Indicator. Okay. So how can we register with Siemens? Well, let me just show that for the purpose of this. Just come here, change here, click here, Siemens, industry support, Siemens, then once you click on that, once you click on this is my own account already. So let me say log out. Then you can create login. You press login first, I guess. It automatically log me in. I don't know. Log out. I want to say please. Okay, use one Snyder component. Oh, the attendance link code is ready already. And we'll be sharing that soon. I don't know if I have account with Schneider, but we'll try that within this class before we go. So once you click on login, because I already have account, that's why it's logging me. Once you click on login, it will act like it want to it will ask for your email and password to login. You will now see under that, don't have an account before, then login or something. You understand? So let's move on back. Let me share the other screen that I'm supposed to share the report as well. Share. Yeah, I think I've used a Schneider component with step 5 before. I can't recall, but I'm sure I should have. It's just the way to find it. That's the only issue. So now let's do this. Let's wrap up. So the attendance link is ready. Let me share that on this page right now. Hold on. So the attendance, that's the attendance link. Please let's make use of it. And I don't know if the host is still here. Please help us share with people on YouTube. Don't let our brothers in the Lord have to enter my DM. So for the indicators, we're using red for stop, to indicate that okay, look at what is happening now. You see what the what's this thing? The indicator is not aligning to the plate. Look at the way it is showing. Let me drop it, you should see. Look at it's showing. And why is it doing this? It's only because I have not defined this door as a mounting surface. So if you don't define it as a mounting surface, just assume it's just a drawing space. You just put it there. So you come here, insert. What do I press now? Okay. Insert. Mounting surface, this. Okay. So after doing that, now let's go and pick the indicator now. You can see that. Can you see that? Then you put it down, red. Then let's say we are using blue. You can also download the indicator from Schneider, Siemens or thereabout. So we don't know here. Put this guy. Yeah. Then we would have what else? Switch, I think. Wait on. They want to try and get the push button. Instead of going through the chart, let's just go here, device, electrical components, push button here, general. Let's see, not this one, not this guy, not this guy, no. Push and push button here. So this is a push button we can make use of. The data does not have the data required. Okay, that means I've not downloaded the data for this guy. Let's try the emergency button. It's just to make sure we're not having to download. So the emergency button is ready for use. So after downloading the emergency, according to maybe one of the ISO standard, I've forgotten, you would have to always add a yellow indicator for your emergency switch button. So it's always cool whenever you put your emergency button, put the yellow indicator to make it visible and distinguish it among other buttons. This is the guys I was looking for. So we have the start push button. Let me just put them under your. No, I don't put them close to the emergency. Start push button. Stop push button. Then, like I request, let's go to the. Okay. Like I requested for in the course, I said we should add what? Selector switch. That okay to select between manual and auto. So I downloaded the selector switch also from Siemens Portal. So for the person asking for Schneider, I'll make sure we do that before we leave. Okay, so this is the selector switch. The same thing we've been doing, view, rotate, insert, define, good, view, rotate again. So define, undo, mounting surface, because we don't want this one to be showing outside after So that's how we define that place as the mounting surface. Well, if I define this back as the mounting surface, when if I put it on the plate, it won't enter. It won't go inside. It will just be showing. It will just stay on this part. So then you copy it. You come back to your. So this is it. This is our selector switch. Bagam. I hope we are being able to use the attendance link to mark attendance. So you not just attend and then we can all see the attendance link, right? I be the attendance code. This so this is this on the door. We can always add more other things. If I want to write name on the panel, you can't see the attendance code, okay? Alfred, please, one of you. This is the attendance code now. I don't know if it has expired or not, but this is the attendance code. I just add, paste it again. So you can always write name. For myself, if I want to write name, I use free card to just create a step file. So now let's go to Schneider and look for, please, I was unable to log in. So let's go to Schneider and look for maybe a component to download. We're not done with this guy. You look at what we have now. This is what we have. So we'll still have to put a fan by the side. The fan also is from Siemens. You go to your Siemens portal, search for the fan, you do due diligence and download your fan. But for me, I've got my fan somewhere here. I've downloaded the guide before to save myself the stress of, okay, look at the fan. But for the lecture, let me just go there to download the fan again. I think, no, there's no time. There's no time. I should go back there to download the file, but no, there's no time. Let's just go here, copy the fan. I already did what you also do. You rotate, define. I already did that. That's why this mounting surface is showing. If you've not done that on any of the stuff, the mounting surface will not show. So then you come back to so we have this already. So watch again. If I want to put the fan, you see, it will even accept it. Why is that? Because I've not defined this side as a mounting surface. So you do what, insert mounting surface, make this side a mounting surface. That way, once you want to put anything, it will automatically accept it. Then you go with your Control V, and you see escape, Control V, and you see, think we're good to go now. Then just bring it closer to the door to avoid story that touches yours. Okay. Can someone tell me why we are not using AC? Maybe in the chat, I don't know. But I feel some people might feel like, why don't we just use AC, or why don't we just use, I don't know, but I feel fan is the best for this practice because we don't have a lot of electronics component, and the enclosure is not, how will I put it? It's just based on the number of components we have in the enclosure. That's why we're not using, what's this guy name called? So for the other side, to add the isolator switch, so someone has been asking about the main isolator. I always prefer is either you add it to the door or you add it by the side. So I'll be using the side for the purpose of today's lecture for my isolator guy. So this is it. You insert, you make it a mounting surface also. mounting surface. Someone said I observed the measurement we took in the enclosure are not being used now. Well, we've been making use of it now. If we not make use of it, how do we get the 30, what's this guy called that we're using? The cable dot. That's what we use for the cable dot. To get the cable, and the 100, that's 50 above and below. So one thing about, once you already have your layout and your calculation done, once you are just placing those guys there, it automatically, okay, AC will require a coolant which condenses as the process continues. Consider, more, a senior man, no, that's not good. Hmm. So, but for this point you raised about the AC in the chat, I said in the last class that the ACs we use for panel design is different from the conventional AC we have at home. The ACs for panel design does not generate noise. I don't know if you've seen major panels. The panels I've seen, once you touch it, once you touch it, once you touch Once you touch you put your hand behind it where the cold air is coming out from, you see that it does not leave water on your hand after removing it, compared to the one we have at home, that once you put your hand and remove it, it will be somehow moist. So the best thing, I'm talking about the spacing of the company. What you calculated was 20%. So the 20% is going to show on the cable, on the DIN rail. That's for Sani Bolu artifact. Going to show on the DIN rail. Not that you start using ruler and something to calculate the space on the DIN rail. So 20% is going to show on as far as you are leaving gap in what you are doing, like in the placement of the component. So now let's add the isolator. Did they have it here? Have I seen it? Electrical component. So let me even show you I think I've seen the ACS today. Yes, this is the AC that they have. Let's say we want to use AC. Look at, you just put your AC here. Let's say you want to make use of an AC. Yeah, I think this is smaller. Okay, this is even a bigger one. So let's say you want to make use of AC, you just put it here. So then, what I'm looking for now is the isolator. You can also download it, but I think I've been here before. Electrical general. So we can always use this process and even see all the components. This is Rita light, panel light, is the one on top. So this panel is a small panel. That's why I'm not dimming it fit of putting light inside. But we can also add light in case we want to. It's not something special. It's not something you can do. This is an HMI. If you want to add this, what is this thing called? A scalar switch. If you want to add scalar switch for Ethernet connection and all of that. So let's see, measuring instrument. Okay, this shows this look more like a logo PLC, but it's not a logo PLC. This shows voltage, everything, robotic board, the voltage, the current, and the likes. I just plug us in, I don't know. I'm not using this guy. There's the one I made use of. Okay. So I think we can now put it here. So this is a safety switch, the isolator switch. It has low point where you can just lock it and then you are good to go. You are good to go. View. Views. And you see this is the part I was talking about, that fan that I said the fan has parts inside that. In case you go and select your depth to be smaller, this part of the fan will be touching the cable tray. I mean the cable dot. So no, my laptop is lagging. Sorry. Have you been able to mark attendance, please? My laptop is lagging. Okay. So I just want us to wrap this up. I want us to see inside. You just hide. Whenever you want to check inside or something, you can just highlight the door, right click, then hide. So you can see inside. This is not touching the cable tray because of we made the depth bigger. So if we are looking at it from this part, you see the fan is not so, but if I have chosen a smaller depth, this fan will be touching this thing. And it will cause a design error whenever the person want to implement. So, and this is the editing bar. For myself, I think this is majorly all the components I added for mine. So this ultrasonic sensor will not be here, as we all know. The ultrasonic sensor is placed. Our ultrasonic sensor, why I even say we should use ultrasonic sensors, because most people will be looking for floating switch to add to their design. And that's quite stressful. I came to EPLAN check if they had ultrasonic sensor, and I saw it. That was why I asked us to use ultrasonic sensor. So what ultrasonic sensor does is that you place it on top of the tank. It sends sound waves to the tank. Then from the feedback from the sound wave, like how many waves return back, that's where it calculates the tank level. From that, you can send. Some use 4 to 20 milliamps, like analog signal back to the PLC where they can calculate. But I stated in the sub that PNP. So PNP send back 24 volts, just like a regular switch and sensors. So that way you can beautifully build that. So I think for tonight, this is okay. The Schneider engineer. Let's go to Schneider Electric. Where's my Chrome? Sorry. So you can see the Schneider page. Let me know. Can you see the Schneider page I'm showing you? Please let me know in the chat if you can see the Schneider page. So I will just continue. We'll look for what you want to look. No. Okay. I'm coming. Okay, I'm coming. I'll rectify that now. So this is the beautiful Schneider Electric. So I don't think I have an account with Schneider. So let's say we're looking for a contactor. Just want to make sure that the step 5 stuff is there. Because I'm sure I've downloaded from Schneider before. Is Olonode still with us, please? Because he was the one that requested for this. So for the case of Schneider, there's no even point stressing myself to this place. I don't think Olonode that asked for it is still here. Let me just click on any of the components. Then you scroll downward. It's still loading. Okay, see. As simple as that, we have the CAD file there. Look at step 5. It's even the first thing that came out. So let me download the step 5 and then import it so you see. So that's why I said, as far as you know their website and the components you're looking for, all major companies provide step 5 for their equipment. So let me share my EPLAN page so we can. I don't think engineer learn on this here because it's not like requested for this and it's not active. So this is it. File the same way I explained before. Import. Sorry, I'm not in the layout space. I don't know if the attendance stuff will still be active because it has been long they dropped the link code.
It is
I
active.
don't- Okay.
It's going to be active for 1 hour.
1 hour. Okay, that's very good. So for the Schneider one, then import the same method, layout space, step file. Then since we just downloaded that for Schneider, we come here. Today, let me make sure this is the one I did. Let me see the timestamp. I think this is it. This is my guy. So look at voila. So this is what we have from Schneider. This is what Schneider has to show for I'm coming. Okay. This is what we have for their own contactor. So you can always use this one too, then you just do the same method, define, copy, then you paste it on your drawing layer space. I think that sums it up. So with this viewpoint of mine, how about the controller for ultrasonic sensor? Where will it be placed? I explained that before. So controller, the ultrasonic sensor, we are using a relay for it, which we already added to our design. If you look at the panel, hide. Let me show from this side. What's up is hanging. Sorry. So look at this is the relay for the controller for the ultrasonic sensor. This relay, this one that is here that I'm pointing at, this is what we're using for it. Hello, so you can see it very well. This one. So this is it in my own drawing. If you come here, the sensor, look at it in my drawing, this relay here. So from the ultrasonic sensor will be placed on top of the tank. Then it will send it 24 volt to the A1 of this. Once the A1 close, then I make use of it. I make use of it in the control side as the K3 here. So it closes. Once it opens, the motor stop, the pumping stop. This is the K1 for the pumping machine. The pump, sorry. Then so once it's closed and open, either way, it's just stop it. So I think that's clear, right? Caleb Oluguwa, I'm sorry. I think that's clear. So with this viewpoint of mine, because like you would have programmed the depth that will be triggered. Okay. That will trigger the relay, right? Yes, you want to get your ultrasonic sensor. Every sensor has tuning. So you can increase the sensing range, reduce the sensing range. So that is during the process of fine-tuning that you'd do all the program, not even programming, just fine-tuning, just it must have what's this thing called? A place where you can increase the sensing range, reduce the sensing range. So you reduce it to where you want the high level limit for the water to get to. So whenever the water pumps to that level, it sends 24 volt out. The cut off power, this happens, so we are good to go. So I think if that's all, if there is any question, please let's start dropping it in the chat because I'm done with the layout design. So I know it's a lot to take in for the very first time and all of that. So I'll always be in the I'll always be on the group, and most people have chatted me before. You have my number. In case you have any, if you are stuck, maybe you are trying to design something, you are looking for a component, you can't. Yeah, definitely. You can go with floating switch. It does not stop your design. It makes sense. But don't let us drag this out. Okay, so as I was saying, in case you have anything to work with, any design you are working with, you are stuck, you need guidance, you need, okay, what can I use here? What can I do for this design? You can always contact me. I'm open to helping anybody. So if you have anything to say, you can raise your hand. I think I'll stop sharing at this point. If you have anything to say, you can raise your hand, then we can just up you. You say what you want to say, then we can call it a day because it's not easy. What's your name on the WhatsApp group? I don't have a name. I don't know how to put it. But don't worry, I was the one that I sent the link for the class this night too. But I can still just, I don't know how to put it. I will watch the video to get better understand. Very much, very much. That would be super helpful. Yeah, this one I dropped my name. That's my name. The semicolon two. Is it semicolon or asterisk two? Okay. So is there any other question before we close it, call it a night, and everybody goes to bed? Where is this guy? Where's my guy? Our Andrew, Engineer Andrew. Let's hear from you now. You said I'm not talking today. Since the 3D on is summer. Yes, two slashes, yes. I don't think it's with us, our Ghanaian brother. Network got me back. Sorry about that. The recording is on YouTube. Okay, Engineer
Hello.
Andrew is ready. Yeah, good evening, Engineer.
Good evening.
Good
Good evening.
evening. Yeah, good evening. I
Yes.
can hear you.
Good evening.
Yeah, I said,
Oh,
how is it? How is it going, Engineer?
but I'm doing good. I'm doing good. But for the past quite, I haven't.
Is it me, or our engineer does not have a good network there?
So I'll find time, and I mean the one on YouTube. I'll get time to, I mean, do things very well.
Okay, okay,
Quite.
that's sweet.
Yeah. So
In case
I'm
you
just
have,
observing. But you guys are really doing well. But
yeah,
yeah.
Aqua
Okay.
network is busy. Yeah, so thank you very much. I really appreciate it. So in case you have any question, you can chat me up or chat engineer Alfred.
Yeah, your name, Engineer Alfred. I have his contacts, but your name, I'm trying to search for it.
My name,
But
we've
I'm
had the
seeing it.
conversation. I'm the one you sent a message concerning your attendance and all of that. There was a time where
Okay,
you
okay,
had,
okay, okay.
yeah, so don't worry.
Okay. Thank
We're
you
good.
very much. Okay.
Yeah, no problem. So well, let's have grace. Let's have the grace. Please, you can unmute yourself and talk. I don't know. I've asked you to unmute. Grace, please. Let's hear from you. Grace, oh, I don't think the personal network is okay. I'm sure it's the network. Caleb, Engineer Caleb. Engineer Caleb.
Yeah,
Please.
good evening, and thank you once again for your time. Is it
Yeah, good
possible
evening,
to
sir.
have like a wiring scheme, like just in that the 3D layout, just like connect this wire to this wire, this
Yes,
wire to this wire?
definitely, definitely. That's the advanced part of EPLAN. You can do your wiring, you can do your drilling, even what is this guy called? You can also do copper bending, all of that there. I think I can share something. I can just show you. Please, let's type my question so you can. No problem. I'm all yes. You can type it. So let me share something real quick so you just see the part of the copper that I'm talking about that you can. that you can also. I'm coming. So you can see the screen now. Let's go to the plan sample. So you can see this panel, you see. I see the earthing bar. Then I'm looking for the one that we had. Copper. We bent copper there and thereabout. Not this one. This one also I did change my. I'm coming. Okay, I think I've seen. So are you sure you can still see this? So this is okay. This is a typical example of this is an air circuit breaker. This is the copper bar behind it. You can bend the copper, do the connection to it. Let me show you the back view so you can see that. This is just what we did is just how will I put it, the foundation. So, and for every project, every topic, everything in life, what you need first is the foundation. Then after the foundation, you build on it. If you are jumping from the foundation to the top of the story building, I'm sure the building will not last. The simulation possibility plan, no, sorry. That's the only limitation I think it has. Kindly share the Excel. Definitely, I'll share it in the group. Please let me tell. Okay. So I think that's all the question we have. If that's all, I want to just give a little. I'm coming, sorry. There's no other hand. I think everybody is okay with the class. So for our project and yes, our end of the phase one project, we'll be getting the questions latest tomorrow or next tomorrow. So for the project and what we want to work on. This Sophia person, we've not heard from you. Are you with us? Sophia.
Yes, I am. Good evening.
Yeah, good evening. How is it going?
It's going well. I'm
Ah,
not able to because I don't have my laptop. Light has been
oh,
bad over it. I've been learning a lot from the classes. Thank
oh,
you.
you don't have your laptop yet. Okay, okay. Yeah, don't worry. As far as the video is always on YouTube, whenever you have a laptop, you can go back to it, watch it. If you have any question, send a DM. You would send a DM, you will get it done. So how much time would we have? Thank you very much, sir. So how much time would we have to complete the phase one project? That will be communicated before what's this thing, Friday or Saturday, you get your final project and then the duration of the project. So we can wrap the phase one up and then see you in phase two. You still hear my voice in phase two though, for the PLC programming. You still hear from me. So I think with that being said, we want to tell everybody have a good night rest and have a great weekend ahead. Thank you very much for attending today's lecture. Good night.
Sorry, Mr. Tola. Good evening. Thank you for thank you for the lecture. Before you go, please can you really help us to know how to identify you on the WhatsApp group?